All right, so prepping for the multiple choice portion of the final. We're just going to work through some of these. Number 4 is the first one we want to take a look at. And yeah, I'm not going to write this whole thing up. Just to read through it, it says that you're standing 270 feet from the base of a cell phone tower. From where you are standing, the angle of elevation to the top of the cell phone tower is 37 degrees. We want to find the height of the cell phone tower. So what we're saying is that we're standing at this point. There's a cell phone tower. We're looking up. This is 37 degrees. We're also told specifically that we're 270 feet away. So we have to assume that that cell phone tower is forming a right angle with the ground. And we're supposed to find the height of the cell phone tower. So this is quickly going to turn into a trig problem. What in this particular case, from my reference angle of 37 degrees, would we all agree that this is the opposite side? And the 270, that's the adjacent side. Everybody agree with that? So if we're talking opposite and adjacent, which trig function comes to mind? So the tangent of 37 degrees is equal to the opposite over the adjacent. Now, there is a problem similar to this on tomorrow's final. Again, that's why it shows up on the review. And I'm very confident that we can successfully do this problem. But what do you suppose the mistake was that some students made? And again, very possible that they messed up the setup, but I would say that the majority of people who missed this in past years that are coming to mind, they did all of this correct, but then their calculator was in radian mode. That hurts, doesn't it? Right? So of course, both, if you do this correctly in degree mode or if you do it incorrectly in radian mode, both of those answer choices are going to show up A, B, C, or D. It's going to be your job to make sure that your calculator is in the right mode for the problems that we're doing. So again, if you don't have a calculator on you right now, please come get one. Again, we want you to absolutely be following your steps along with this here. But again, step 1, once we get here, we have to make sure that we're in degree mode. I'm trying to isolate the x, so I'm going to multiply 270 on both sides so that we create that cancellation. So the calculator step x is going to be equal to, again, 270 times the tangent of 37 degrees. Of course, making triple sure that you're in degree mode. Oh, here you are. Thanks, Darren. All right, so what do we end up with? 270 times the tangent of 37 degrees? 203.5 feet, approximately. Something like that. So as we look back, does that answer make sense? Could it be, do we think 203.5 feet approximately seems like a reasonable answer? I would say so. All right. How would we know that it's not a reasonable answer? Maybe, I don't want to spend too much time on this, but if we ended up with something like, I don't know, well, anything greater than 270, should that bring up a red flag? Anything greater than 270? Why is that? Or even right triangles in general. Let's look at it this way. If this is a 37 degree angle, how big is this angle up here? 53 degrees. Okay, so again, hopefully we're all feeling good about the fact that if this is a right triangle, then this is going to be our hypotenuse. And yes, that's the largest side. We know that. But if this is a 53 degree angle, doesn't that mean that has to be the second biggest side? 37 degrees is the smallest angle, so 203.5 has to be the smallest side. And if we ended up getting 303 or something like that, or some other value that's bigger than 270, we know we made a mistake in there someplace. Does that make sense how we could look at that? All right, like I said, last thing I want to do is confuse you right now with geometry talk, but again, sometimes we can catch mistakes as we are making them. Okay? Or as you're doing a multiple choice test, even before you do one speck of the math, after you draw your sketch, you can probably start to eliminate some of the answer choices. Especially if your calculator's in the wrong mode, we can catch some of those mistakes that way. All right, so that was number 4. Number 6 is the next one that we were asked to take a look at. Let's see, we've got the point -4, 9. I should probably read through it first. -4, 9, it lies on the terminal side of a rotational angle in standard position. We want to find the secant of theta. Okay. So quick sketch here. Excuse me. Let's see. Number 6, it says that we're at -4, +9. Again, very rough sketch here. Identify, again, that's -4, 9. Meaning that from the origin I went left 4 up 9. I think we all understand how we got there. So this is the angle that has been created. Okay. So if we were to continue on and we want to find the secant of theta, don't we kind of owe it to ourselves to make a sketch of a right triangle? Dropping down like this. Okay. So once we have that right triangle, again, let's just think about how we got to that point. We said that we went left 4, we went up 9. The thing we have to watch out for, again, the common mistake is that students will forget the negative symbol on the 4. As long as we're disciplined enough not to do that, we're going to be in pretty good shape. As we continue on, if I'm looking at my reference angle, again right here for theta, again, we know that really this was theta, but we understand how we're going to address this. If we're to take a look at doing a really poor job of stumbling through. I guess maybe we'll just back it all the way. What is secant the reciprocal of? Cosine. So what is cosine? What over what? Adjacent over hypotenuse. So what can we say that secant is going to be if it's simply the reciprocal of cosine? Hypotenuse over the adjacent. Good. So if we're looking at the hypotenuse over the adjacent, at this moment right now, we could fill in and say, yeah, the adjacent, that looks like that's going to be -4. Does everybody agree? Hypotenuse, we've got a little bit more work to do, right? What do I have to do to figure out the hypotenuse, please? Pythagorean theorem off to the side. Good. So 9 squared plus -4 squared is equal to x squared. I'm going to ruin the surprise. We're going to get the square root of 97. If I'm not mistaken here. Is that going to be positive or negative? Positive. Will our hypotenuse ever be negative? Never. It doesn't matter which quadrant you're in. Again, your opposites and adjacents, obviously they can be positive or negative, like they are in this problem, but again, the hypotenuse will always have that positive value. So we're left with root 97 over -4. All that I would encourage you to do is bring the negative symbol out front, or even up top, something like that is what we're looking for the secant. Okay? Any questions on number 6 before we move on? All right, number 10. Number 10, taking a look at number 10, it says in triangle ABC, excuse me, it says that A is 64 degrees, side A is 11.2, and B is 11.2. We want to find C. Okay, so a lot of different ways that we could approach this problem, but is this going to be a law of sines or a law of cosines problem? Law of cosines, okay, the way that it sits based on my given information. Is there an easier way, though? There is an easier way. Again, I want to be very clear. Could you use the law of cosines right now? Absolutely. Absolutely you could. But let's be honest, if you're going to use the law of cosines, I guess number 1, you have to remember the law of cosines. Okay? Which maybe you do, maybe you don't. Again, that's kind of going to be more of an individual thing. But if we were to make a quick sketch, one of the things that I'm noticing, and maybe I should write this down, we were given that angle A is 64 degrees. We were given that side A was 11.2. We were given that side we're looking for side B was also 11.2. So the moment I realize that these two sides are the exact same, do we actually know one more angle? We're going to know angle B here pretty quickly, aren't we? Because if the two sides are the same, their opposite angles have to also be the same. All right? So if we were to, again, I guess the way that I originally sketched this up, as you could have seen on my answer key, we were given that angle A was 64 degrees. We were given that side A, which would be across from angle A, of course, is 11.2. Side B over here was 11.2. And then we were able to just conclude that angle B was 64 degrees. Well, I just brought up angle B. Could we now make that jump to angle C as well? Because all 3 angles of the triangle have to add up to how much? 180. So how big is angle C then, please? 52 degrees. Now again, we haven't used any law of sines, law of cosines, anything like that to this point, and we just figured out 5 of the 6 pieces. Unfortunately, the one that's still missing, that sixth and final piece, the one that we're actually searching for, it will require law of sines. Okay? So, again, I just want to be very clear. If you didn't see it this way, if you just, all right, I'm given, let's see, two sides and the angle, and specifically, again, two sides and the angle, I can just automatically at that moment, we can make that assumption that the law of cosines it's going to be working. Again, we could have used that. But the way that we're going to do this problem, if I'm just looking for side C, can we set it up this way that C over the sine of angle C is equal to, and really your choice, whichever one you want to use, A over the sine of angle A or B over the sine of angle B. This is going to be the law of sines. Now, you don't have to do all three. I would encourage you to just use this. And now when we plug in, C is my variable. That's what we're searching for. Over the sine of angle C, which we said was 52 degrees, that's got to be equal to side A, which is 11.2, over the sine of angle A, which was given as 64 degrees. Okay? So far, so good? So again, one of the places that people run into trouble, what mode should our calculator be in? It should absolutely be in degrees. So again, it's worth double checking, triple checking. So if we were to cross multiply and do all this stuff, the math that we're going to see is that C times the sine of 64 degrees is equal, I'm just cross multiplying is all, 11.2 times the sine of 52 degrees. The goal was to get C isolated. So I'm going to divide both sides by the sine of 64 degrees. So we're going to end up with 11.2 times the sine of 52 degrees all over the sine of 64 degrees. So again, an awful lot of calculator work here, yes, but what do we end up saying that C is equal to in number 10? About 9.82. Again, I think I went a little bit further. Initially I said C was equal to 9.8195 and went about it that way. Now again, to me this was easier. Maybe you went law of cosine. I'm just very curious. How many people did this problem by using law of cosines? Okay? How many people did it the way I did? That leaves a lot of people who either haven't done it or just looked at the answer on the key, so that doesn't make me feel that much better. Do we want to see law of cosines? It's an option. It's an option. Okay. Well, you will not be given the formula, no. But if you were to use law of cosines in this case, how could we have set this up? Again, just as a reminder, again, I guess what I had jotted down on this, a squared is equal to b squared plus c squared minus 2bc times the cosine of a. Now, could we have used this to solve for c? This is kind of like the blanket statement. Yeah, we could have, but wouldn't it have been smarter to finagle this to where we have c squared is equal to a squared plus b squared minus 2ab times the cosine of c? That's gonna be a little bit of a problem, right? Why is this, the second one that I wrote in black, why is this going to be problematic? We don't know angle C. If we knew angle C at the beginning, we probably would have used law of sines anyway. Does that make sense? Okay, so what I'm getting at is that we probably would have had to stay here, even though, well, you know, C isn't isolated nicely. You're going to have to finagle it around and move some things in order to make it work anyway. Yes?
How do you know which one to use in law of sines?
So typically it's based on what you're given. So kind of just rule of thumb would be that if you can use law of sines, we're going to use law of sines. If you can't set it up to where you can get it to work, then we have to fall back to law of cosines. But you were able to make it work with law of sines? Oh, okay. So yeah, I wonder if something, we can take a look at it, but I wonder if something was, you said that like you found an angle but you didn't really find it type thing, but yeah, usually that's kind of the go-to. If you can do the law of sines, that's going to be the goal because it's easier to use. When you can't use law of sines, that's when law of cosines is kind of our fault.